Good morning, everyone. My name is Aubrey Pomorski, and I am the project manager and one of the structural engineers with Jake Engineering. With me today, I have Kenzie Kahn, our transportation engineer, Emil Friesvillen, our other structural engineer, and John Bone, our water resources engineer. We are working on Eastgate development, and that means we will be creating a road that connects Silhavy and Sturdy. That proposed road is shown in dotted red above. We will also be building 2 new buildings shown in yellow and blue, and a parking lot shown in red to accommodate these buildings. And our water resources engineer will be designing the drainage and a culvert to accommodate all of these new developments. And now I'm going to pass it on to our transportation engineer, Kenzie.
Thank you. Hello, everyone. As Aubrey said, I'm Kenzie, and I'm the transportation engineer for Jake Engineering. And I have been tasked with a new roadway connecting Sturdy Road and Silhavy Road. In addition to this, I will be renovating the 2 intersections that connect to this. As you can see, I have designed a roundabout, a signalized, and a 2-way stop. Each of these have been designed through the Valparaiso City standards, which are 12-foot lanes, 30 feet curb radius, and 100 feet entry pockets. In addition to that, the roundabout inscribed diameter is 80 feet. The next 3 alternatives are the Silhavy Road intersections. Each of these is a T intersection, a signalized, and a roundabout. As you can see here, this roundabout is a 45-foot inscribed diameter, which is a little different compared to the Sturdy Road one because there's less area to work with and the turns are a little bit narrower. And then you can see in the T intersection, there's 3 approaches, and the signalized and roundabout, there are 4 approaches. So those 2, signalized and roundabout, will be connected to the Boilermaker Court Road. So here you can see my intersection analysis summary. Here, this is a report taken from Briscoe used by Trip Generations for the turn movements that calculated the level of service, which will be ranked for each intersection. From here, the level of service will be taken into account as well as the cost analysis in order to determine the best alternative. And for the next 3 alternatives, we have new road limits. So the first one is a directly through to a connection to Silhavy Road. The second one is along the existing pavement with a connection to Boilermaker Court. And the last one is along the existing pavement with a connection to Silhavy Road. As you can see, 1 and 3 will have a 3 approach intersection, and number 2 will have a 4 approach, would be the signalized and the roundabout, which also can be more expensive because there's 4 approaches instead of 2. And then in addition to this, the horizontal alignment will be taken into account to provide a more efficient and minimize the cost and enviro damage. So my last alternative is a parking lot design. Here, I was taking the square footage of each of the 2 proposed buildings and to determine the number of spaces for each of the parking lot. These were taken from the City of Valparaiso parking ordinance, and from here I calculated 200 spaces that were needed for this parking lot. I designed my parking lot for 217 spaces in case of change for the future. Each of these are 20 by 9 standard spaces. And then in addition to the 217, I designed 5 handicap spots that are 20 by 9, in addition to a 20 by 5 access aisle for handicap, and then 2 van spaces that are 20 by 11 with also the access aisle. In addition to that, I have 2 bike racks and 1 loading zone. And then for my next steps, it would be to rank the intersections to find the best alternative, to determine the horizontal alignment, and then do a cost analysis. And now we will hear from our structural engineer, Emil.
Thank you. As one of 2 engineers for Jake Engineering, I am in charge of the retail and commercial office space, as well as senior living residential community. I'm asked to provide 12,000 square feet of retail and commercial space, as well as 25,000 square feet of senior living residential community. Additionally, I'm adding 2,000 square feet of outdoor covered area, which is either available to the public or can be private. I'm considering 3 different alternatives. The first 2 are going to follow the same layout as you see here, with the first being a steel structure and the second being made of reinforced concrete. Both are located here on the east side of the parking lot, and as you can see on the first floor, there's going to be retail and commercial office space in the front facing the parking lot, and in the back there's going to be 11,500 square feet of residential area. On the second floor, you'll find the remaining 12,500 square feet of residential space in the front of the building, and in the back there'll be room for a rooftop patio, which is going to supply the 2,000 square feet of outdoor covered area. At this point in the design process, I started to look into the structural layout of various elements. I'm doing this by using a rough estimate of the depth and length ratios between different members. Further, I'm assuming that for a steel building, I'll use a minimum of a W8 beam up to a maximum of a W18. And this range of beam depths, I'm going to be able to use in my depth and length ratio to get a typical span or typical column spacing. To do a preliminary layout, as you see here. The second alternative is following the same procedure, but instead of being made of steel, it's made of concrete, so I'm making some different assumption about the beam depths. Here I'm using a minimum of a 12-inch beam depth up to a maximum of 24 inches. And again, I can use the depth and length relationship to come up with typical spans and typical distances between members. And again, the layout is very preliminary and it's going to be slightly different than the first alternative, which is made of steel based on the difference in material properties, which is going to be apparent in the depth and length relationships. The third alternative is going to be a 1-story steel structure. Again, it is located on the east side of the parking lot and will in the front again have retail and commercial office space. In the back, there's going to be 2 corridors, each providing 12,000 square feet of residential area. And in between the 2 corridors, there'll be room for the 2,000 square feet of covered outdoor space, as well as room for a garden, which I know John is going to touch on later and why that can be beneficial in an overall design. Again, I'm looking at the preliminary layouts for the structural elements. Again, using since it is a steel building, I'm using the assumption of a minimum of a W8 up to a W18. And again, using the depth and length relationships to come up with typical spans and a preliminary layout for the column spacings. The next steps for me is to use the designs I have now to keep building on them. So the stuff I've showed you today is very much subject to change, but it's used as like a stepping stone to move on with. Once I come up with final designs for each alternative, I'll be better equipped to make a cost analysis of each to use that in my, when choosing the optimal design for not just us as a team, but especially for the client. That's all from me. I'm going to pass it over to John, who's going to talk about the water resources part of our project.
All right. For the water resources side of this project, my scope is to design systems that will adequately control stormwater runoff that occurs on the site due to this new development. I will be responsible for treating the first 1 inch of runoff to improve the general water quality as well as to remove 50% of the total nitrogen content. My design will also need to prevent flooding from larger storms and follow all existing stormwater regulations set by the City of Valparaiso. In this site, you can see the topography of the site. So in the west, that's where we intend on putting our parking lot and our buildings. And that area also sits on top of a hill. So that will cause the water to split and go into the direction shown by the blue arrows. So I will need to capture all the water going in each direction, as well as the water going on either side of the road. In the east, you can also see that a creek exists in that area. So that is where I will need to put the culvert in order to put the road in that location. This is my first alternative. So as you can see in the area marked in green, those represent rain gardens, which will act as my water treatment source. I have them in each direction to catch water going in each direction. Each of those is attached to the area in tan, which represent detention basins, to provide extra storage in case of flooding. The area in yellow, those are vegetated swales, which will act as some sort of water treatment as well as transporting it to another location. The area in purple represents added vegetation, and I added it there because in the area there's very steep grades, which would make building a basin in that area difficult. So I just decided to add a little extra vegetation to at least help filter out some of the solids. On the right, you can see the area in blue represents the culvert, which will need to go in, and you will see that culvert in all of my alternatives. For alternative 2, I decided to, instead of placing a rain garden in the north and the south of the development area, just use vegetated swales to transport the water east to a larger rain garden. So that first rain garden, that will catch the water flowing off the parking lot and the buildings, while the rain garden to the west will capture the water flowing off of the road. In my third alternative, this features the building that Emil mentioned, where because of its shape, I can include a rain garden in the courtyard of that building, which will allow me to catch the water that lands on top of that building and treat it right there. This design also uses vegetated swales to further transport the water to the east, to get it all into one larger rain garden to make it more efficient. That's also attached to a detention basin, and I also used a culvert to allow the water from the north side of the road to enter in the rain garden in the south side of the road. For my final alternative, I added in impervious surface for the parking lot as well as for the buildings, which will allow more water to infiltrate and therefore decrease the total volume that I will need to capture in the rest of my designs. This allows me to use less total area
analysis and use those to decide which alternative would be best for my design. And I will be able to present upon that on my next presentation that I will be giving to you guys. Speaking of our next presentations, we will all have our alternatives decided upon and analyzed to the best of our abilities, and that concludes our presentation. Now I would like to open the floor for questions.
That's me? So I have a couple questions. So the first one is on the roadway. So you showed kind of the plan view or the horizontal. Are there any concerns, like elevation-wise, or trying to, kind of do the vertical profile, or what you might be crossing over?
Yes, for sure. That was definitely planned for the future to determine the horizontal alignment because for each alignment, I want to provide the most efficient and most cost, or minimize the cost and the environmental damage. So depending on the horizontal alignment, the intersection, or the road alignment will be chosen from there.
Okay. And where the culvert is, are you doing anything special in that area?
John is, from our Water Resources Department, will be designing and helping me with the culvert.
Okay, sounds good. And then, John, so on your pervious, you mentioned, I think alternative 3, you have pervious surfaces, including the buildings.
Right.
So what are you thinking about the buildings there?
For the building, I would probably have to use some sort of garden as well, just plant vegetation up there. It wouldn't be the same kind of pavement as I would use on the roadway or the parking lot. Yeah, I'd have to make some sort of garden.
Okay. And then you'll let the structural engineer know that you're putting...
I will do that. Cool. That's your ways.
So could you go back to your alternative 1 slide, please? Thanks. So on the other alternatives, I could see like what's happening to the water, like on the east part of the road. There were some detention ponds there or something, I think. But what happens to the water in this alternative that doesn't make it to the detention ponds on the west?
Well, I also assumed that any water that would fall on the road would be caught by the curbs, and so that would lead it to the general area, and then I would also add drainage to those curbs to lead it straight into the rain garden. I will admit this first alternative is my worst one, so it's okay if you see stuff wrong with it.
So the slope of the road is going to go from east to west there?
It goes from west to east.
Oh, okay, so it's going to the rain garden.
Right.
Yeah. Okay. Okay. I guess that's it. Thanks.
Let's stay on this slide for a minute. John, you said you're going to design the culvert.
Yeah.
Have you looked at that at all yet? How big does this need to be? Sizing and the type.
Yeah, I've looked into the watershed associated with that area. So the creek that exists there only goes up maybe another like half mile or so into a residential community. So it's not a necessarily large creek. But yeah, I have delineated the watersheds, and yeah, it shouldn't be too much of an issue to design for. Any other questions?
Anything from all of you? Anything you want? All right, well, thank you.